So we started section 2.3 last time. The title is simply Product and Quotient Rules, which we've talked about both of those things, but there is another component of this section that we haven't talked about, and that is trig rules. So we've encountered a couple of trig derivatives already back in section 2.2. The derivative of sine was cosine, and the derivative of cosine was negative sine. These are the other four. All right, so if you're like, I haven't done any trig, it doesn't matter. Unless you've done calculus with trig, nobody's done it. Okay, so this is specific related to calculus. So we're going to start with derivative of tangent, and these are paired up on purpose the way they are because their derivative forms are quite similar in pairs. Sine and cosine go back and forth, right? So those were nice to kind of group together. The derivative of tangent is secant squared of x. So the derivative of tangent x, secant squared of x. And the derivative of cotangent is negative cosecant squared of x. So they group together nicely. They have very similar forms for their derivatives. And again, we see that negative showing up. And interestingly enough, I'm going to actually write them on here just so that I can show you an interesting pattern in a moment. The derivative of sine was cosine, right? And the derivative of cosine was what? Negative sine. We'll come back up to that in a minute. All right, the last two on this slide actually pair up nicely as well. The derivative of secant of x is secant x tangent x. And the derivative of cosecant x is negative cosecant x cotangent x. The first thing I'd like to point out is signs. Half of the derivatives of trig functions, signs, become negative, and half of them stay positive. Do you notice anything that's in common about everything that has a negative derivative? That one's negative, and that one's negative. Not what I'm looking for. There's something a lot more straightforward. Any ideas, Robert?
They start with C.
They're all cofunctions. You're right. They all start with C. So they're all the cofunctions. This is a cotangent, a cosecant, and a cosine. So if you're taking the derivative of a cofunction, you're going to get a negative derivative. It's helpful because signs often catch us off guard. You miss something just by a silly sign. So the derivative of the trig functions that are cofunctions are negative, and the derivative of the trig functions that are not cofunctions are positive. That's handy. Something else that you might notice is that the new ones anyway, when I do a cofunction derivative, I get the cofunction components, right? Right, so cotangent becomes cosecant squared. And cosecant has cosecant cotangent. And then the other ones don't. That doesn't work for my sines and cosines, which we did before, but it works for these. So the reason I'm mentioning it is because you have to know them by memory when you get to the gateway next Wednesday, right? So for what we're doing today and for your homeworks and everything, you can continue to use your notes to remind yourself, but when we get to Wednesday next week, you have to have those memorized. And that's a nice mnemonic one to remember. So we're going to use the product and quotient rules that we did last time, along with these new trig identities, and we're going to do a few more examples, okay? So we have this one. Doesn't involve products and quotients on this one. It just involves trig and polynomials. So on this one, we talked about this piece here at the beginning, back when we did simple derivative rules or basic derivative rules in section 2.2. It's often, not always, but it's often helpful when we have something like this to rewrite it in a different form. Any idea how this could be rewritten so that it's easier to do the derivative of? Yeah. Now, could you do the product or the quotient rule with it? You could. But it's kind of overkill. Quotient rule we want to usually do when there's like no other way to do it. Quotient rule to do with this one is definitely overkill because I can rewrite 1 over x as x to the negative 1. And then I have negative 12 secant x So we're able to take the derivative then using basic rules from 2.2 for the first part, and then the new trig rules for the second part. So what's the derivative of x to the negative 1? Yeah, so I'm going to write it first in the other form first. Do you know what it would be in that form? Yeah, negative 1x to the negative 2. Okay, so we bring the negative 1 down, we decrease the exponent by 1. We're going to rewrite it like Hayden just mentioned here in a moment in a different form when we clean it up, but we're going to do it this way first with our basic derivative rules. What's the derivative of secant? Secant x, tangent x. Okay, so what do we do with the 12? We bring it along, right? It's a coefficient multiplier. It comes along for the ride. It is a negative 12, so it will stay a negative 12. And then the derivative of secant, as y'all mentioned, is secant x tangent x. And that's what we would leave it as, at least potentially if you chose to, on the gateway, okay? But if you happen to notice, or if you're doing the homeworks and so forth, we are going to finish it out like Hayden mentioned, and we're going to rewrite it as negative 1 on top, or you can put the negative in front, x squared on bottom, minus the 12 secant x tangent x. Okay, any questions on that? Okay. This one, we see sine and cosine, but what else do we see? It's a product, right? Okay, this is a product rule. Anytime you have two functions of x that are multiplied together, which this is, and I'll just draw a line in between them to make it really clear. The sine of x is being multiplied by the cosine of x, right? So we have to use the product rule. All right, so with the product rule, I didn't actually re-go over it today, so this will be our re-going over it problem. What we do first is just rewrite the first piece. So we just rewrite sine of x. And then I need the derivative of cosine. So what is the derivative of cosine x? Good. It's negative sine of x. And making sure we put it in parentheses to indicate that it's multiplication, because if we leave the parentheses off, it looks like subtraction, right? Okay. What happens next in the product rule? Addition, yeah. So if we were doing quotient rule, we'd have subtraction. When we're doing product rule, we have addition. And then I need the derivative of sine, the first piece. So what's the derivative of sine x? Yeah, cosine x. And then we rewrite the second piece, cosine x again. The gateway, we would leave it like that. There's a couple of ways that we can clean this up in terms of how they look, but they're like equivalent. So I'm going to put the negative here at the beginning. Sine x times sine x is sine squared, and it can be written like that. If that bothers you, you're also welcome to write it like this. Neither one's really wrong. The first one's a little bit more compact just simply because I don't need the parentheses around the sign. What you're not allowed to do is you're not allowed to write it like this. Any idea why that would be bad notation?
Because x is squared.
Yeah, so Daniel's right. It looks like the x is being squared, right? And in fact, that's exactly how we would write it if x were being squared. So we do not want to use this notation. We have to somehow indicate that the sign value is being squared. So you can write it between the sign and the x, or you can write it in parentheses with it on the outside. The other part is a little easier because it's just cosine. So I can do the same thing, cosine squared like this. I don't have to worry about negative, is why I said it was easier. Or I can write it like this. Okay, so this is sort of an or statement. Notationally, if you were looking at like an answer key, they're going to write it the first way. Not because the second way is wrong, but because this first way is just a little more compact. Okay, is that all right? Cool. All right, let's try another one. What kinds of rules do you see that we're going to have to use for this problem? Quotient rule and the tangent rule, right? We're going to need to use the tangent rule itself. All right, so the quotient rule says, I start with the denominator. The denominator is tangent, and I simply rewrite it. Okay, the denominator rewritten. And I need the derivative of the numerator. So what is the derivative of 2 minus 3x? Negative 3. Okay, now what? Subtract. The quotient rule has subtraction between the pieces that are on top. And then we need to do the other half of this. So the other half takes the numerator, so 2 minus 3x, and the derivative of the denominator. So what is the derivative of tangent? Yeah, it's secant squared of x. And I'm going to always write my squared in between them. If you don't like that, like I said, you can do it like I showed you in the last problem. Okay, is that all right? That's my numerator. What will my denominator be? Yeah, the tangent of x squared. So again, I'm going to write it like this. If you want to put it in parentheses and write the square on the outside, go for it. Okay, so on the gateway, you would stop right there. I hope I'm encouraging you to love the gateway already. At least a little bit, right? Because you don't have to do any simplification. All right, so for homework, we are going to simplify some things out and clean things up. So the first piece would be negative 3 tangent of x. I've got to distribute the secant through and a negative through as well. So what will the first piece be after that, like the next piece? Yeah, will it be negative or positive? Negative. So negative 2 secant squared of x. And then I'll have a positive 3x secant squared of x. Good grief. My penmanship's not going so good today. It still isn't. That too. Here we go. All over the tangent squared of x. So the only thing I have in my denominator is tangents, and I don't have tangents in every term in the numerator, right? So there isn't any simplification that I can do between them, and none of my pieces on the top, they don't combine, right? None of them are like terms. So at that point, we are stopped. So this is g prime of x in as cleaned up a form as we're going to work with anyway. Okay, is that right? Okay. We have one more in this lesson, and then we are going to start briefly into the next lesson. Number 8. Tell me what you think you would do first, or what you notice about it.
You distribute the 3 into it?
Yeah, I would distribute the 3 through. There's no reason not to, right? So that is what I would do first. I would write this as 3 minus 3 sine of x over 2 cosine of x. Is that okay? If there's a simple cleanup that we can do to make it the derivative process have less, parentheses and things like that, yeah, go for it. All right, so what is the basic rule I'm going to be using on this particular one? Yeah, it's the quotient rule. All right, so somebody tell me, what's the first piece of my quotient rule? Yeah, the denominator, so it's 2 cosine of x. Then what? Derivative of the numerator. Okay, so what's the derivative of 3 minus 3 sine x? Okay, so the derivative of 3 part's going to go away, right? So we really only have to do the 3 sine x. The derivative of sine is, what did you say? Brock, I thought you were talking to me. Were you?
I was, but I was probably wrong.
No, I think you're fine. I just wanted to make sure we were slowed down.
Cosine?
Yeah, so there's going to be the cosine part, right? And the 3 is going to stay. So the negative 3 at the beginning is going to stay. And then the derivative of sine x is cosine x. Is that all right? It's derivative of my numerator. Then what? Subtraction. Then what? Yep, the numerator, which is the 3 minus 3 sine x. And then what? Yeah, the derivative of the denominator. So it is negative because the derivative of cosine is negative sine. So if we notice that right away, we can put the negative in front of the 2, and then it would be sine there, sine x. Did I get all my pieces right for the top? Okay, great. What am I going to do on the bottom? Squared. So what will happen when I do 2 cosine of x and then I square all of that? I'm going to get a 4, yeah? And then the cosine squared of x. So make sure that you remember to square the 2. On the gateway, we would stop. But we definitely have some cleanup we can do for now. So I have 2 cosine x times negative 3 cosine x. What will that give me?
6 cosine squared.
Negative 6 cosine squared of x. Perfect. And then if you'll notice on the second piece, there's a negative on the outside that needs to be distributed. I've also got a negative 2 sine x to distribute through. So I'm trying to distribute 2 negatives, right? So we're not going to do that, right? Because the negative times the negative is a positive. So I don't need to distribute a negative through. But I will distribute the 2 sine x through, like this. So we have, let's see, we have 3 times 2 sine x. What's that going to give me? Positive 6 sine of x. Then what? All right, and then we have minus 6 sine squared of x. Or 6, yeah, that's fine. Over cosine, 4 cosine squared of x. There is an additional step, and this is from Trig, that we can do to clean up the numerator. So those of you who do see it, can somebody tell me what you might see that might be able to be cleaned up?
All the coefficients mentioned.
What's that?
Divide all the coefficients.
That's one thing. We are going to be able to simplify by changing all of our coefficients because all of our coefficients are even. So that is correct. We might as well do that now since you noticed that. Sure. So this is negative 3 cosine squared x plus 3 sine of x minus 3 sine squared of x over 2 cosine squared of x. Do you see it, Alex?
Cosine squared plus sine squared.
Yeah. So there's a Pythagorean identity, and you got it, so good job. The sine squared of x plus the cosine squared of x is equal to 1. So this is the first time we've used it in this class, but it is one of the 3 sets of identities that I need you to memorize, even if it's not ones you've done in a trig class before. Okay, so again, if you haven't printed those out, I would encourage you to do so. You may not directly see it happening, but it is there. It's right here. These 2 pieces, if I factor out the negative 3, are sine squared and cosine squared, and they're the same sign, right? So if I take this and I pull out the negative 3, I will have cosine squared x plus sine squared x. And then I still have the plus 3 sine x on top. That part doesn't get affected. It's just the other 2 pieces that join up. And then the part that's in parentheses is equal to 1. Okay, notice we almost had that happen over here. Why didn't we have that happen here? Yeah, one of them was negative and one of them was positive. So the Pythagorean identity only works when they're both the same sign, whatever the sign is, okay? So this piece that's in parentheses now is equal to 1. So we actually end up having it, kind of simplify down quite a bit to be negative 3 plus 3 sine x on top and 2 cosine squared x on bottom. What was my function name? K prime. Okay, so some of you are like, well, what happens if I forget to do this step? Well, you're not going to do it on the gateway anyway. But if you forgot to do this step on, say, like a test or a quiz, you'd miss a little bit, but it wouldn't be like the end of your life, I promise. You'd miss tiny little bits of points because you didn't recognize an identity. And it's probably going to happen at some point that all of us are going to not recognize an identity where we can simplify something, so it's okay. All right? Awesome.